All right, another day on section 4.3, and here we're going to bring in some properties of that definite integral that we set up yesterday. And so if we go and we look at what we've got going here, this definite integral thing, we're going to start with this is my function f of x, and f of x is everything we're going to look at this red area with the lower bound of a and an upper bound of b. And here are some properties. If I'm taking my definite integral and I am integrating starting at a and ending also at a, meaning if those bounds match, think about how wide that integral would be. That would have no width, and if it would have no width, can it have any two-dimensional area? No. So if your bounds match, your area under a curve is always going to be 0. Part B. This time it looks like our bounds are switched. That's no good. Well, if you want to switch those bounds back, what you do, if you want to rewrite that integral to match what you wanted it to be, meaning going from a to b of f of x dx, the only thing you have to do is throw an opposite sign on whatever that integral would have been written originally. So if your bounds are switched, you can switch them back if you want to. You just need to bring in a negative sign. Okay, part C, integral from a to b of f of x dx. If you want to, you can always introduce an intermediate value for part C. So if I wanted, let's say that I came over here and I said, here is x equals c, which would be a value that would look something like that. Now what I'm looking at, I see now two regions. I see a region that goes from a to c, and I see a region that goes from c to b. So if I want to, I can rewrite this integral as the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So you can introduce an intermediate value in between a and b if you want to make two separate integrals out of it. Part D, we've got this extra constant there. If you want to, you can always take that constant out in front of your integral from a to b of f of x dx. And in part E, I see two terms. And if you want to, that means you can rewrite your integral as the integral from a to b of f of x dx plus or minus, whatever it is that fits in the problem, the integral from a to b of g of x dx. More than one term means more than one potential integral, if you want to look at it that way. Now, I've got two problems down here for us to work on. So number one, you've got some given information. You've got some information given about f of x and g of x and h of x. Okay, well, what does that mean? Well, I want to find over here 4 times the integral from 1 to 3 of g of x. Well, the integral from 1 to 3 of g of x. Well, here's g of x. The integral from 1 to 3 of g of x is given to have a value of 4. So what I really have here is I have 4 times that value, which also happens to be 4, minus the integral from 1 to 3 of f of x dx, which over here was given to be 5, minus 3 times the integral of h of x dx. Well, h of x dx, integral from 1 to 3, is given to be that 2. So my minus 3 times 2, total these up. Here's a 16 minus a 5 minus a 6. Looks like 16 minus 5 would be 11. Minus 6 is going to ultimately give me a 5 as I go to figure that out. Now that's a pretty straightforward one, a little different style than maybe we're used to. When now down here on number 2, we're going to have to work at a little bit. Now I'm going to zoom this in so I've got a little bit, we can see it a little bit better. So what we have this time is we have some information given to us. We have information given to us about the integral from 0 to 2 and the integral from 0 to 6. But over here we're asked questions about the integral from 2 to 6. So let's look at this integral from 2 to 6 first. If I wanted to, I see 1, 2 terms. So let's rewrite this as the integral from 2 to 6 of f of x dx plus the integral from 2 to 6 of 7 dx. So now we're looking at two separate problems. So let's say we looked at the integral from 2 to 6 of f of x dx. Well, f of x dx, we don't know over here what the integral from 2 to 6 is. But if I was making a picture, here's 2, here's 6, that integral from 2 to 6 of f of x dx would be saying, let's say we drew a picture in. Let's say, for example, I would be looking for that area. Well, if I look at the picture I have right now, the integral from 2 to 6 of my function should be the same thing as adding are taking the integral from 0 to 6 and subtracting off the integral from 0 to 2. So knowing that, well, let's see. The integral from 2 to 6 is what we're solving for. The integral from 0 to 6 is given to be 12, minus the integral from 0 to 2 was given to be negative 3. 12 minus negative 3 would be 15 for the integral from 2 to 6 of f of x dx. Plus, now we got to deal with this integral from 2 to 6 of 7. Well, how would that work? That might work a little bit differently. What would 7 look like as a graph? Maybe we can use that geometry we talked about. 7 would be up here. That would be a horizontal line. That horizontal line going from 2 to 6 would give me a rectangle that's 4 units wide by 7 units tall. Let's use geometry to figure out that area. 4 times 7 is a 28. Take my 15, add on my 28. That looks like I'm going to have an area or an integral value of about 43 square units. So there's a way to kind of work that thing out, and get an idea what's going on with shortcuts.